Hey everybody, this is Larry. This is day 24 of the Leetcode Daily Challenge. I don't know why I hesitated. I knew what day it was. Hit the like button, subscribe button, join me on Discord. Let me know what you think about today's forum. I have to find the button because everything's moved. Still complaining about the new UI, but that's another story. Yeah, today I'm kind of resting a little bit. I hurt my foot the other day. It's very embarrassing, but did I mention it yesterday? I don't think I did, but maybe if I didn't, or if you did, or what? If you did. If you've heard this story before, just feel free to fast forward. I don't remember if I mentioned it. But 2 days ago, I was running on the treadmill because it is very cold outside. It is 12 degrees Fahrenheit. What is that in negative 11 degrees Celsius, in case you're from a country with a reasonable temperature system. But negative 11 degrees Celsius, because it sounds cooler now that I say it. Yeah, so, well, it sounds cooler, but I was running inside. So I did one outside yesterday, and that was like 13 Fahrenheit, so like maybe negative 9 or something. Anyway, yeah, so I was running on a treadmill. And treadmill is kind of boring, to be honest. So I was watching it on my iPad. Actually, this one right here. I have my iPad next to me. Actually, didn't, does it show up on screen? Okay, whatever. It's an iPad. You know what an iPad looks like anyway. Well, it's a mini iPad, in case you are wondering why it's so small. It's not because I got huge hands. So maybe I do anyway. Who knows? I don't really measure my hands, if you know what I mean. But anyway, yeah. So so I was running on the treadmill. I have my iPad. I was watching a movie. Kinds of Kindness, actually. I don't know if anyone is a film buff, but I'm not a film buff anymore just because I don't feel like I have time. But on the treadmill, I guess that's like the one time I've been watching movies. I don't know. Anyway, it's a movie by Yorgos Lanthimos. I'm saying his name wrong, probably. It's not an endorsement because I don't know yet. It's a very confusing movie. I don't know how I feel, honestly. But in any case, yeah, so I was running in the puppet, running on the treadmill, and then suddenly, in the middle of that movie, if you have watched it, also the director's great. One of my low-key dark comedy of all time, The Lobster director. Okay, anyway, it's not that important. Sorry, I'm ranting a little bit. Anyway, I was running, watching the movie, kind of, actually a slow pace, just to kind of get the cardio, get the system going, and then suddenly. And this is not spoiler, I hope, if you haven't watched it. But there was just a nudity scene, and it just kind of popped out of nowhere. So of course I was like, like what the? And then I kind of reached to kind of get it, and the story after that is that I just fell off. I mean, I didn't like fall down or anything. I just kind of like rolled off. But I think like as I was like, I don't know, I kicked some stuff. Anyway, it's bad. My foot is like really in pain today. Even though yesterday, like I said, I went and it was okay. I don't know if it's like I need to warm up or I don't know. But today it's in a lot of pain. So anyway, so that's my day. Yeah. Okay. So let's take a look at today's problem. With that said, and maybe an ironic name to the problem: find eventual safe states, because I was not safe. Maybe I need to find an eventual safe state. Anyway, okay. Let's take a look. So we have a graph of n nodes, each with oh yeah, remember to hit the like button, hit the subscribe button. Also, tell me your favorite or maybe your most embarrassing gym stories in the comments. I'm curious. Oh, I just twisted my foot a little bit, feeling that one. But yeah, let me know. All right, the graph is represented by zero index 2D integer array graph, where graph sub I is an integer array of node adjacent to node I, meaning that there is an edge from node I to each node in graph sub I. A node is a terminal node if there's no outgoing edge. Okay, a node is a safe node if every possible path starting from that node leads to a terminal node. Okay, another safe node. Return an array containing all the safe nodes in the graph. The answer can be sorted in ascending order. Okay, I mean, so here we have 2. Why is 0 not a safe node if every possible leads to terminal node? Oh, because there's a cycle. Okay, so 0, 1, 3 has a cycle, so no Gucci. Okay, the arrows here is kind of confusing, but okay. I think the way that I would attack this problem is just think about which the word that I say a lot, invariants, right? I say that a lot because you try and figure out, well, and actually I think induction is actually a good the mathematical principle of induction is actually a good use of this idea of invariance, right? And what I mean by that is that in induction, I mean, it is kind of just building like, okay, let's say f of 0 is equal to whatever, f of 1 is equal to based on f of 0, so then you kind of build one at a time because f of 1 is true, or f of 0 is true, some other thing happens, some other property, then f of 1 is true, and f of 2 is true, right? So that's like, I mean, I know that's a very fast way of, and hand-wavy way of saying, of explaining induction, but part of that induction, that idea, that proof, is this invariant of, okay, well, these things don't change, and that's why this thing is true, right? And then you kind of use that same logic everywhere. So that when I talk about invariant, I think not everyone understands what I mean, and I'm not gonna lie, it's an elementary topic, but it's definitely not easy. I mean, it's simple but not easy, right? Like a lot of things in life. And I think a lot, and this is me as well when I was starting out, like in class and stuff, like way back in the day, right? I definitely kind of just like, yeah, I don't know what that means, but it doesn't seem like I need to know what that means, so I'm just gonna ignore it and keep, just solving problems or doing homework or whatever, right? And it took me like a long time, and even on this channel, honestly, to some degree, like maybe I still thought about things in terms of invariance, but I just didn't really, definitely did not articulate it. I didn't think about it explicitly, right? Now I'm trying to be a little bit better about it, and that's what I mean by in this channel, if you, I don't know why you would, and I don't even know if you can, but if you watched like the first year, which is now 5 years ago, I've had this channel for 5 years or something like that, right? Wow, that is a long time. Anyway, I didn't explain it in this way, but now I get improvements, hopefully. And also, this is also why, like, if you watch sometimes people comment on my older videos, and yeah, maybe sometimes they're better, but a lot of the times I feel like I'm better now. Anyway, that aside, let's go. So what does invariants have to do with this particular problem, right? Well, you just try to figure out something that doesn't change, right? And well, first of all, here the terminal node doesn't change. So, okay, so we can build out all the terminal nodes. And by definition, all the terminal nodes are safe nodes, right? And then next, you can build up that. Well, now that you kind of like, you could even think of it as kind of just removing those nodes a little bit maybe, and then think, okay, well, if we remove those nodes, what nodes are the new terminal nodes, right? Because that means that one step away, they're a safe node because they lead to it, but now they're the new terminal nodes, and so forth, right? And that's when I say so forth, that is the invariant part, is that you can now, based on this idea, based on this strategy, the thing is that every iteration of your algorithm, if you will, it does not change these ideas, right? And of course, if you're very, if you're well trained, and if you're able to kind of play around with this specific sort of problem before, then you'll maybe recognize this as topological sorting, right? This is the two main ways that I always consider about topological sorting. This top down or bottoms up, if you will. It's not quite that, because that's more like a dynamic programming terminology. But there is essentially like a queue-based version and a stack-based version. And they both have different properties. But for this one, they should be sorted, but that part is easy. It's just like a binary thing for each node, right? So okay. But I don't even think that, just to be clear, I don't think the topological sort thing is an explicit thing, and even like necessary. Like if someone asked me how to solve this, I wouldn't just be like, oh, just use topological sort, but because that's too many jumps, doesn't make sense, right? And also, you can even think of it as topological sort is an idea in which there is an algorithm and implementation, right? But that implementation might do other things, and this is one of those other things, right? That doesn't. Hopefully, if you're a set theory person, that made sense. But anyway, okay. So let's do it. What is the input in? Graph sub I is okay. So this is already an adjacency list, so we don't have to do anything. Maybe, right? And all we have to do is just I'm gonna do a BFS because I feel like for whatever reason I've been doing that lately. Maybe I need to swap. No, I'm very good at DFS as well. So okay, so yeah, so n is equal to the length of graph, and maybe today we'll just use v for a number of vertices, right? And maybe today we'll use a p to correctly spell graph. But yeah, and then now right for I. If length of graph sub I is equal to 0, then here, then this is a terminal node because it has no outgoing edges. That's it. Right? So here maybe we can say a terminal is equal to oh, and maybe just a boolean to mark it as done. I'm just thinking ahead a little bit. Maybe done, I don't even need to. Maybe I just need to write like edges is equal to none times v, right? And then here we can say edges sub I is equal to length of graph sub I. And the reason why this is important is because that now it shows how many outgoing edges from here. Yeah. But I think I'm just being lazy and sloppy. Because the reason why is because I'm trying to do it by being lazy, but not I can't. I think I need because basically, and this is because okay, well, yeah, okay. Sorry, I'm trying to kind of recollect my thought. Let me reboot my computer. Clearly, I'm stuck in some kind of weird loop. But okay, yeah. So what I was going to write is something like this, right? Because I is good. And then now, but the next thing you want to do is go, okay, well, the things that point at me, now let's remove those edges. But if you look at the data structure now, we don't actually have a easy way of doing that. So I guess we have to go the reverse. We have to create a reverse graph, right? And that's what I need to do. I guess this is technically, you could even make it a list times v, right? And you have to be careful about not using the other notation with like multiplication. Yeah. So here we set terminal right? And then maybe we have a q. And we do q dot append I, and this is regular. Did I say buffer search? I meant q based things. I guess today I'm just a little bit weird. But you have to do it in 2 passes, I guess. I was trying to think if I can do it in 1 pass, but I don't think so. Maybe, right? And then now for j in graph sub I, then now we want to say that there's a edge from I to j. So then in the reverse graph, we want to create a thing of, if I could type it correctly, from j to I, right? And then now, yeah. And then now we can say edges sub j, which we don't have a j for, we could decrement by 1 because we removed an edge. And then what's j? Well, j is, it should be a 4j, right? For j in graph sub. No, that doesn't make sense. It's on the reverse graph, right? So it's in reverse graph of I, right? And that's it. Oh yeah, well, maybe I shouldn't do it here because I think it complicates things a little bit. Because I think what I want to do instead is just have it do it when we relax as y, right? So current is equal to q dot pop left, though pop also doesn't matter. That's actually, then you can write both versions of the topological sort with pop or pop left, I suppose. But yeah, And now here for j in our graph subcurrent, then now we want to say edges of j, we decrement, and if edges of j is equal to 0, oh yeah, and here it's not a length anymore, I see. Then now we want to append j, and terminal append j, right? And that's it. And of course we have to return the answer sorted, and that part is straightforward-ish. And yeah, looks okay. Let's give it a quick submit. Yeah, not too bad, right? Yeah, that's it. Like I said, this is essentially topological sort, but the key part of that and part of the recognition is also like I don't actually I don't memorize or remember really the topological sort idea, right? Or I don't remember the algorithm precisely, but I just remember the idea. And the idea for topological sort that I remember is just that, well, you just take a note. Like the way that I think about it is with classes, right? Like taking classes, like school classes, school course or whatever. There are two ways to think about it, right? One is going it's kind of top down, right? Of like, okay, let's take let's say I want to take physics 120, physics 400, right? Well, what does that require? Well, that requires physics 301, and 301 requires physics 201 or whatever, and physics 201 requires calculus and physics 101, something like that, right? And you could think about it as a tree. That I guess it doesn't have to be a tree as long as it's acyclic, right? But now you have that graph, and top down would be me going, okay, well, what I just did, right? I go, okay, I want to take 400 class, and then that means I have to take this, that means I have to take this, and that's the recursive way of doing topological sort. And then at the end, you'll be like, oh, because I have to take this class because there's no prerequisite. And then the other way of thinking about it is this idea of like, okay, well, I want to take every class which has no prerequisite, right? Because I already met, or just take one at a time, really. I want to take a class that I can currently take because there's no prerequisite. I can take it and, I could just go to class, right? So I take it, I'm Gucci. And then now, after you take that class or took that class, you go, okay, well, now what can I take, right? For example, like, oh, I get to uni or college, I don't know. And I go, okay, well, I have all these prereqs done, or I took AP classes, or whatever, I don't know. So today, or this semester, I take Calc 1, because that's the class I can take. And then next year, I go, okay, well, what can I do? Now that I have a Calc 1 in my is it resume, report card? What do they call it anymore? I don't remember anymore. I'm too old for this. But yeah, and then you take Calc 2, and then so forth. So it's kind of like, so in that way, it's kind of like, bottoms up, right? So those are the two ideas that I have for topological sort, and from those two ideas I can write all the code, right? So that's why I don't really remember algorithms. I just remember ideas for the most part. Yeah, that is all I have for this one. Let me know what you think. This is actually going to be dominated by this sorting at the end, and there's really no way around it, right? Because you can think about in the worst case, maybe 6 points to, no, the other way around. 0 points to 1, points to 2, and then you're going to pop 6 first, and then 5, and then 4, and then 3, and then 2, and then 1. You have to sort it no matter what. And you can do any number of things. So that's probably going to be the lower bound. So that ends up being v log v, which is the number of vertices. But everything else is linear, right? This is just, we look at each edge once, we look at each node once. V plus E, which is linear, and that's it. That is all I have for this one. Let me know. Oh, excuse me. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.